All right, now we are working on solving exponential inequalities, and this is the last thing we're going to do um, for this section, right? And pretty much, guys, this is what we did at the start when we were solving exponential equations, right? The only difference is now we have an inequality, and so really the only really big difference between equations and inequalities is when you multiply or divide by a negative number, right? So if you multiply or divide by a negative number, right, then you must flip your inequality sign, all right? And that's the case for any kind of inequality when you're solving that, right, is whenever you multiply or divide by a negative number, and usually that's one of the last things you do, one of your last steps, you got to flip that sign around. So it's going the other direction. All right, so I let b be greater than 1, all right? So we're not dealing with decay, we're dealing with growth. It says b to the x is greater than b to the y if and only if x is greater than y. So this is just basically what we did last time, except that it's greater than, less than, all that, right? So nothing revelatory here. All right, now we are going to do these the same way. So the big thing is just you have to get the same base. All right, and so once you get things the same base, then you just basically you isolate your exponents, right? Isolate your exponents, and then you solve for x. All right, so get the same base, isolate the exponents, and then solve for x. And I'll show you what I mean by isolating the exponent here. I'm going to move this up a little bit. Give me a little room. All right, so 16 and 8, the common base that will work for 16 and 8 is 16 is 2 to the 4th and 8 is 2 to the 3rd. So I'm going to rewrite this as 2 to the 4th to the 2x minus 3 power is less than 2 to the 3rd. All right, so if I write this instead as 2 to the 4th times 2x minus 3, right, write it that way, less than 2 to the 3rd, now I isolate my exponents. So I'm going to pull that out, and I'm going to do 4 times 2x minus 3 is less than 3. And you're going to keep the sign going the same way that it was before, right? And then it's just a matter of just solve it the way you know how to solve inequalities. Let's do our distributive property. 4 times 2x is 8x. 4 times negative 3 is negative 12 minus 3. Okay, let's move that over, right? Now, when you add or subtract, when you add negative numbers, right, you're not flipping anything. It's just the multiplication and division. So you have 8x less than 15, right? We're going to divide both sides by 8, and you're going to get x is less than 15 eighths. All right, so x is less than basically just a little less than 2, right? So 1 7/8. Okay, so let's try one more, right? Or 2 more. Let's try 2 more. All right, so we have 1 to the 243rd, right? Which is what is that? That is my brain's not working. It's not 17. Is that it's something to the 3rd power. Might be. It's not 6 to the 3rd. Is it 7 to the 3rd? 7. No, it's 343. All right. So obviously, what we need to do is we need to figure out what's going on with 243. So let's see how many times 3 goes into it, right? So let's go 243. 243 divided by 3 is 81. So this is actually 1 over 3 to the 5th, right? Because 81 is 3 to the 4th. So it's one more factor. So you have 1 over 2 minus 1 is greater than or equal to 1 over 3 to the 5th. All right, so now what I got to do is I don't really have the same base yet because this is down here. So I'm going to rewrite this using negative exponents because I just got a 1 there. So let's blitz this, and let's go 3, the 2x minus 1 is greater than or equal to negative, or sorry, not negative. Simons, what are you doing? All right, it is, let me erase, it is 3 to the negative 5th power, right? So that's the equivalent expression of this. And now I have the same base, right? I got 3 here, I got 3 here. So I'm going to set 2x minus 1 is greater than or equal to negative 5. We're going to add 1 to both sides. So that's going to give you negative 4 over here, and then 2x. Divide by 2, and you get x is greater than or equal to negative 2. All right? And if I put it in, that says 3 to the 2 times negative 2 is negative 4 minus 1. So that is, if I fix it, 3 to the negative 5th is greater than or equal to 1 to the 1 over 243. Well, 3 to the negative 5th is the same as 1 over 3 to the 5th. And we know from doing this already that that is 3 to the 5th. So this checks out. Okay, now we're going to do the same thing with this one. So we have 2 over x plus 2 is greater than 1. And I can write 32 in base 2, right? That's 32 is 2 to the 5th, right? So we have 1 over 2 to the 5th. And now we're going to do exactly what we did last time, where we're going to rewrite this using a negative exponent. So we have 2 to the x plus 1, or x plus 2, my bad, is greater than 2 to the negative 5th. So we have x plus 2 is greater than negative 5. Subtract 2 from both, and you get x is greater than negative 7. So any number greater than negative 7 will make this true. Well, let's try that. Let's try negative 8, right? So if I use negative 8, I have 2 to the negative 8 plus 2 is greater than 1 over that. Well, 2 to the negative 8 plus 2 is 2 to the negative 6th, right? And 2 to the, oh, you know what? I'm being stupid. Negative 8 is not greater than negative 7. Guys, oh, guys. Let's do negative 6 instead. Let's put that in, because negative 8 is smaller than negative 7, right? So that's why I was looking at this. I'm like, wait a minute, this isn't going to work, right? Because I usually try to keep my brain like one step ahead of what I'm doing. But yeah, so let's try negative 6 and see if it works. So we have 2 to the negative 6 plus 2, because negative 6 is larger than negative 7. I did that common rookie mistake of forgetting that negative numbers. It's like the opposite, right? So you have 2 to the negative 4th is greater than or equal to 1/32. Well, this is 1 over 2 to the 4th, which is equivalent to 1/16. And 1/16 is bigger than 1/32, right? And so yeah, so it works out. All right, so this is our answer. And good work, guys. So have fun with these, and try not to make as many mistakes as I make. And we'll see you at the next one, okay?